All right, gang, it's time to talk about one of the more powerful technologies in 802.11n's arsenal, and that is transmit beamforming. Dun dun dun. I mean, just sounds kind of intimidating, doesn't it? Well, let's talk about what this does. And our scenario that we see in the slide is a great example because I have, notice, on the access point, 3 transmitters, 3 antennas that are transmitters. On the receiving workstation here, I have 1 receiving antenna. We're going to assume for this scenario, because it works best in this scenario, that this station is essentially plunked down on a work desk, a workspace. It's not in motion, roaming from place to place. Beamforming is a technology that works best with multiple transmitters on a single receiver when everything is stationary in space. And here's why. The signal that is being sent from these three transmitters is going to have a certain waveform. And of course, that waveform is going to be received by the one receiver. Unfortunately, depending on what happens in terms of reflective surfaces, remember, multipath can cause signals to be out of phase. Notice these 3 signals, the waveform, some is coming up, some's coming up a lot, one's actually going down. Remember, if a wave is coming up and at the same time a wave is going down, they're out of phase and they actually cancel each other's signal, like noise canceling headphones. So that's bad. That's a classic multipath issue, right? Transmit beamforming corrects for this and turns it into a strength. What transmit beamforming will do is recognize a good signal and then adjust its other antenna so that the other waves that are sending the same signal, because remember we've only got 1 receiving antenna, so we can only really send 1 stream, 1 antenna at a time. What I can do though is I could adjust the phase of the waveform so that if this waveform basically is showing up 0.2 milliseconds late, and this waveform right here is showing up 0.4 milliseconds late, then I can adjust the beamform so that the wave is essentially leaving out this antenna 0.2 seconds early. I can adjust it so that it's leaving out this antenna 0.4 seconds early. So I'm changing when the antenna release that signal so that after we account for the reflective distance discrepancies that happen in a multipath situation, what I end up with is essentially 3 waveforms that are synchronized and they're all getting there at the same time. Now the antenna has received the same signal intensified. A beam has formed to push this signal straight from the 3 antenna that are sending it to the 1 antenna that is receiving it. And I end up with good, clear signal. So let's review. We're sending it so that the signal is improved. Used when we have 1 antenna, right? Because if I have multiple antennas, then we'll do other things to split the signal up and do other technologies like that. Magnitude and phase are adjusted dynamically by the transmitter with client feedback if the client is 802.11n. So between these N access point and workstation, the workstation said, yeah, I got it, but man, on this particular waveform showed up 0.2 milliseconds late. Oh, okay, let me adjust for that. Is that better? Yeah, now we're getting it. Bing, and everybody's happy. Transmit beamforming, an 802.11n technology to improve the quality of signal.